Hello students, I'm Kevin Ford, Commander of Expedition 34 on the International Space Station. Welcome aboard our International Space Station. Today we're going to do some in-classroom demos of a gyro LEGO bricks model that you've built and had a chance to study in the classroom. We also have the same model here in microgravity of space, and we're going to get our gyro model out, take a look at a few of the programs you programmed on Earth. You've seen how they reacted on Earth, I hope, or maybe you will today. And I'm going to show you how those same programs react with this model in the microgravity of the space environment. So let me go get the model. I'll be right back. Okay, here we are, space fans, with our LEGO bricks gyro model again. And I'm back. This time we're going to run what's called the Gyro On program. You've loaded the software through a laptop computer to your NXT, or maybe what we call it up here is Next, onboard computer for the gyro. And your program is programmed up just exactly the same way mine is. I think when I push the button on this one, it's going to run for 15 seconds, and then it's going to do a hard break at the end. The difference between your demo and my demo is I'm going to let mine free float in the microgravity of space. I just want a quick word about gyroscopes. We use the gyroscopes right now. I have 4 of them over my head on the outside of the International Space Station, and those gyroscopes are being used to stabilize our space station. We can move those gyros around to control the attitude, and when we want to hold a particular position, those gyroscopes help us to do that. It's a gyroscopic principle that's very valuable in spaceflight. So here's the gyroscopic model, the LEGO bricks model, and this is again the Gyro On program. I'm going to start it. It's going to spin the gyro up, and then I'm going to let it go so it can free float. And I hope it's right here in your field of view. Okay, so here we go. I'm going to try to release it real nicely. Here we go. Pay particular attention to the end of this program. I think it does a hard break at the end. Okay, here we go. And there you have it. Mine looked a little bit different than what you see down on Earth on your tabletop or what have you. But that is the Gyro On program right there. Okay, so with that, you guys can go back to your classroom and talk about what you saw. Let me go program up for the next run. Okay, space fans, I am back this time, and I've programmed up our gyro model to run the Gyro Touch program this time. I know you've also programmed yours up to run. The difference between this run and the previous run is we're going to initiate it with the touch sensor this time. So the touch sensor is on board here and all ready to go. And also at the end of this program, it is going to coast to a stop instead of doing a hard break to a stop. Okay? So make guesses about what your observations will be in microgravity, if anything will be different with the touch sensor, and if it might look different when the gyroscope coasts to a stop. Okay, we ready to go? Here we go. I'm going to try to stabilize it out here one time really nice again and push. All right, and that was the Gyro Touch program. My observation was that the touch sensor worked just fine in space. The coast to stop looked a little bit different. One thing you might think about as we go through these runs is, why is it when I release it and the gyro is spinning, does it slowly start to spin the other way, as opposed to just keeping the gyro spinning and staying stationary? I think that's an interesting question for you and the teachers to answer in the classroom. I have my own ideas. Okay, I am back with you. This time we are going to run a program called the Gyro Ultrasonic program, which again you've programmed through your computers. I hope you have the exact same program I do. It's the same model, but we also have an ultrasonic sensor on the front of this model that we hadn't talked about previously. We still have the touch sensor as well. This time we're going to put both to use. We're going to use the ultrasonic sensor to stop the motion of the gyro after a period of time. So instead of shutting down automatically, it'll stop with the ultrasonic sensor this time. It's programmed up to detect something in front of it using sound waves. Sound waves work through some kind of medium like air or water or even steel or something. Sound can propagate through all those things. In this case, we have air inside our space station, the same, almost exactly like you have it in your classrooms back home. We have standard sea level pressure in here, temperature and humidity, so the air inside might be expected to propagate sound just in exactly the same way it does in your classroom. And with that, we can use this ultrasonic sensor. Hopefully there's nothing in here that's ultrasonic that would disturb it and cause any problems with our sensor. If there were, that might be an issue. We'll see, I guess. So I'm going to begin this program again with the touch sensor, let it stabilize, and then after a period of time with it running, we will stop it with the ultrasonic sensor. Hopefully I can get my hand in front of it and stop it. All right, so here we go. All right, the gyro is spinning. Again, we see a little bit of counter spin. Why does it do that is a good question for you to ask. I'm going to try to put my hand in front of the ultrasonic sensor there. As the ultrasonic sensor came by, I put my hand in front of it. It stopped it. That looked like a hard brake to me. I think that's how it was programmed up. But I hope you can see that demo and see what that looked like in the absence of gravity. All right, we're going to have one more to do. I'm going to go get that one programmed up for you, and I'll be right back with you for our last demonstration in this session. I hope you're having as much fun as I am. Okay, back with you for the last of our demonstrations here in the microgravity environment of the International Space Station. So this time we're going to run a program called the Gyro Light program. And the Gyro Light program, we have it set up to run just like you do at home, hopefully, at 4 different speeds. We're going to start with 25% power, and then we'll look at 50% power, 75%, and 100% power, or RPMs. And then I'm going to read you the data at the end of each pass, and then we'll start the next one. And what we're kind of interested in is, does the model react in different ways depending on the speed of the gyroscope? Does the faster the gyroscope spins make the model, the spacecraft, if you will, because this is a spacecraft right now. It's flying through space. It's a satellite inside our satellite, the space station. So we'll see if it's more stable at higher spin rates. Does it react differently in different ways? And we'll see if it reacts kind of again in the way you would expect it to. Would you expect it just to sit here with the gyroscope spinning, or would you expect there to be some kind of a counter reaction? And I'll let your teachers talk all about the equal and opposite reactions from forces on objects, and the same thing with moments on objects, things that that react to torques and make an object twist or turn and change orientations in space as opposed to moving and translating in space. So these are all great questions for you to talk about in your classroom. And I'll let your teachers take care of that. So let's go ahead and start this little demonstration. We're going to use the start button for the 25% power, and then we'll use the touch sensor for all the subsequent demonstrations. Okay, so here we go. I've got my little feet down here and my feet plate to help keep me stable in the space station. Otherwise, I'd just be all over the place. Okay, so again, this is the Gyro Light program, programmed up in just exactly the same way you programmed yours in the classroom. Okay, here's number one. All right, and there's our model run. Let me see if I can see the data. It's difficult in this environment. Revolutions, 34.5. Time in seconds was 20.009, almost exactly. 20 seconds. RPM was 103.453. That's what I'm reading on the screen of the next. Okay, now we're going to step up the power. It'll be twice what it was before, 50% power. So here we go, nice stable model. And here we go. All right, very impressive. The data on this one, Revolutions made 68, time in seconds 20.007, and RPM was 203.929 is what we had for data on our NXT, our next onboard computer. Okay, so it's waiting for me now to push the touch sensor one more time. We're going to do this at 75% power and see if it's even more stable than before. Here we go. All right, that was pretty aggressive profile there at 75% power. Revolutions made 82, time in seconds 20.01, RPM 245.877 is the data on the NXT. Okay, we have one more demonstration to do here as part of this on-orbit lesson in microgravity, and we're going to do 100% power this time on the motor. Everything is holding together perfectly. Our model is in great shape, and it's excited about doing its best performance for you right now. So here we go, right out in front of the camera, 100%. All right, that one went just a little crazy there. I'm going to give you the data. I might do that one for you one more time just because it was starting to slide out the bottom of your field of view. Revolutions made 104.5. Time in seconds was 20.8007, and RPMs were 313.39. So that was a pretty active profile. So I'm going to pause it now. I'm going to take it through the first 3 steps because I think those were good, and then run it one more time at 100% power. Okay, and because it drifted out the bottom of the screen, I'm going to give it one more chance here. Maybe put it up a little bit higher so it stays in your field of view the whole time so you can see the final run at 100% power. Again, using the light sensor to pick up the revolutions and all the data, and I'll read it to you at the end. So here we go. I'm going to start it with the touch sensor, and we'll see if full power on our gyro LEGO bricks model is stable. And there you go, just a little final rotation rate on it. Picked up a little bit of angular momentum, a little angular velocity from somewhere. I'll let you and your teachers figure out where it came from in the process of spinning this model up. I hope you really enjoyed your time aboard the International Space Station and enjoyed the lesson. I'm always happy to show you these things in microgravity. I'm Kevin Ford from Expedition 34 on the International Space Station. Have fun in your classrooms. All right, I'm back with you for a little bonus footage here from our gyro model. And this time we're going to not just release it and look at it at the different speeds, but we're going to make some little inputs to it, because if it's stable, it should resist any kind of little inputs I give it. So I'm going to try to be consistent with the 25, 50, 75%, and 100% power. And after I get it spinning, I'm going to give it, I've got two little feet here on the front of it, opposite the touch sensor. And I'm going to try to put in a perfect moment into it by pushing down on one and up on the other at the same time. Now, and this thing is not spinning at all, and I let it free float. And I come in here, I'm going to try to get it stable, and I let it free float. And I put a little bit of a couple on it by pushing down on one and up on the other. Here's the result in motion. So this is with absolutely no gyro running whatsoever. This is just our model. And you can see it's just making one quick tumble. All right, now I'm going to start the model by pushing the button, let it stabilize at 25% power, and then I'll make the same, try to make the exact same input I just made. So here we go. All right, so our gyroscope is running. I'm going to release it, and I'm going to make this little input. And we do get some motion out of it. It's a little bit different motion. A little nutation there, a little reaction at the end. All right, and we're going to do it one more time. This time this will be at 50% power, so I'll try to stabilize it and make a little bit of an input through a pure moment on the two little feet up here. Here we go. Okay, a little bit different motion that time. Up to 75% power now. Here we go. There's our little input. And now you see something going on where the gyroscope is really making a difference in the stability and the orientation of the object, I think. So that was 75% power. And now one more time, we're going to do it at full speed this time, 100%. Here we go. All right, and there is your gyro Lego bricks model in action. A little bit of advanced.